Cheers, guys.
I'm the host now, so let's share screen. There we go. All right, you should have a screen live now. I hope at least. Yeah, all right. So yeah, welcome from my side as well. Today we'll build a friendly .NET SDK to connect to JetBrains space. I actually just put the JetBrains in the title there because with all of the Mars rovers landing and additional traffic that orbits Mars, it's probably good to make that clear that we're not going to space. We're actually building something to connect to JetBrains space. The idea of this talk is to talk a little bit about JetBrains space, what it is, what it can do for you. I don't want to make this a marketing speech by any means, but I do want you to realize that it's a massive product. And as a massive product, we obviously wanted to build a proper HTTP API for that, but also make it easier for other developers to actually start working with it, build integration with it, build applications for it, things like that. So we'll start with that, quickly go through space, what it is, what it can do for you, and then dive into the actual SDK, how we're using code generation, and how we try to focus on developer experience, with the idea that if you ever have to build an SDK or a framework that other people will use, that you can take away some of the concepts and ideas that we brought in there. By the way, if you search for my name and you have to drop out at some point, there's obviously going to be the recording, I guess. But also this talk is in written format on my blog with a couple of additional things that I can't show during a regular session. So if you're interested, head over there and there's more information to be found. All right, let's start with the beginning and let's talk a little bit about JetBrains space. So back in December this year, and actually in December previous year, we released the first EAP version of JetBrains space, and we released a final version, or at least a 1.0 version last December. And JetBrains space is an integrated team environment. I know that sounds quite of a marketing term, but we were thinking as a developer, you have an integrated developer environment, an IDE. As JetBrains, we try to bring you IDEs and stuff like that. But we also want to make it easier for teams to collaborate and work together. And that's what an integrated team environment is about. So the idea there is that you have people and teams who are all using JetBrains space. You have a calendar in there, you have absences like vacation, you have a chatting there. So all of those things are in there to essentially manage people and teams, so that people can also figure out which teams are there, how to reach someone to get something done, or if you're searching someone from sales or marketing, you can actually go into the team directory, figure out who they are, when they work, how to reach them, things like that. Now, obviously, if you want to integrate people and teams in a tool, you also want to be able to work on projects. So in space, you have projects that are workspaces for your team, where people and teams kind of get together and have Git hosting, have a wiki to work on documents, have issue tracking, checklists, you name it, it's there. Essentially trying to make it possible for people and teams to collaborate with one another. So that's the idea of an integrated team environment. Now, I know this is really a marketing slide, so I'm going to quickly jump into a small demo to give you a better idea of what it looks like. So if you have a space instance, ideally, you'll have an organization on space where multiple people in your organization are working, and everyone in the organization will have this homepage with their calendar for today and the next day, so you can click through it. This is actually kind of a boring calendar, but at some point you'll see that more items show up there. There's actually also a full calendar view. If for some reason you need the full calendar, go to days, you can schedule meetings, all of that is in there. Also from this homepage, you will see that you can follow members and teams, which means I'm part of the software development team here, so I can see who are my teammates. I can see who's on vacation. If that is the case, I can also see who is at work. If I want, I can also look at the entire calendar for the team. So for example, if I want to schedule a team drink or something, I'll be able to see that, for example, next week should work because no one is on vacation. I can follow teams because this gives me at a glance information about who is available, who can I reach, who can I work with. My team is there, but also the people and the teams that I follow. So you'll see this list that has no title on top. I can follow people that I work with very often to quickly see at a glance that, for example, Hadi Smith here is unavailable. So I know I can't contact that person today. I'll see my code reviews that I have to work on. There's blog posts that people can post to a specific location in the office or to a specific group of people in the office. So that, for example, you can post about a fire drill to a certain office, or you can post about the fact that there's a team drink to a certain office or to a certain team. So those blog posts really serve to communicate with people in a more elaborate way than a regular chat, but still target the people you actually want to target so that you also don't get overwhelmed with information. You'll see if you hover people that you'll see their profile, you'll see their role, you'll see their location as well. You can chat, you can email, you can look at their schedule. If you go to location, you will find that in location, I think there's a Copenhagen office here where we can look at who is there. For example, this person. You can look on a plan. I know in these COVID times, it's probably not very useful to have office plans and office layouts, which apparently doesn't even render this time, probably because of COVID. But you get the idea, it's easy to find information there. On top of that, you'll have projects where you have Git hosting. Inside of that Git hosting, you will be able to see all of the files that are there. For every file, you'll see that people can add comments through the UI there. So typically things that don't go in code comments, but go in space here are discussions about what something means, what something does, what is an alternative to something. You can chat about those things within the source code. You can reply, reopen. I'm working here in a code view. The other people that I tag will be able to use this just from chat with a little bit of context about which file I'm working in. There's code reviews, there's a package repository, there's issue boards, there's actually working with issues. Everything in space can also be a to-do. So whether you have an issue, there's this lightning bolt icon that you can click, which will add this item to my personal to-do. Right now, I will see on the left here that I just added that issue. I'll be able to see meetings that I have to follow up, documents that I have to follow up. Literally everything in space can be a to-do as well. If you have to-dos, you can actually go there and, for example, go to a chat message that has been sent and follow up on a chat message. Typically, if you're using Slack or Teams, it's really hard to keep track of what you promised to someone or what action items were there. In space, no more. You just click the lightning bolt icon and you'll have a chat or a thread or a message in your to-do list. So everything can really be a to-do list there. That also, again, integrates with meetings. So, for example, writing a blog post about the new feature is something that you will want to do, actually want to block some time for in your agenda. So you'll be able to create a meeting for that and actually schedule, for example, half an hour to get that blog post out. So all of these things are in there. I know this was really a whirlwind demo of a couple of things, and it doesn't do the product justice to go over it that quickly. But again, it's not the goal of this presentation. The goal of this small demo is that JetBrains Space is huge. Everything is there in there: team directory, calendar, meetings, that to-do list, software development, artifacts. There's package repositories. All of that is there. There's also a Space HTTP API. So you've seen that in that integrated team environment, there's a lot of information. And the more information you actually put into Space, the more value you will get out of it. To give you an example, there's a number of integrations between all of the parts of Space out of the box. So you'll see people who are on vacation, which is kind of nice if you want to do a code review and you want to find someone who has to look at your code. You can actually see that that person is maybe on vacation for 2 weeks and pick someone else in the company to look at whatever you have. There's calendar integration in blog posts. Everything can be a to-do item. You can target blog posts to locations and teams and all of that. But what with external integrations? How do you extend this? Because not everything that we have out of the box is going to be sufficient for everyone. What do you want to build? Maybe you have an existing system and you want to integrate with Space and import all of your data. Maybe you want to write a webhook on some CI system that you have outside of Space, because that's also in Space, but maybe something outside, or a monitoring tool that posts a message to a chat. Maybe you want to provision users and teams and locations programmatically based on an Office 365 directory that you may have. Maybe you want to build some dashboards on which projects have open issues, what is going on in there. whatever. We don't know what you want to build. We have some good ideas of what we can offer out of the box, but typically every organization is going to build some sort of integration to extend whatever we have there out of the box. So our main goal from the start was to open up everything that is in space and actually make it possible for you to do anything that you can do through the UI and more through an HTTP API. Now, we've seen that there's lots and lots and lots of features and information in space. So that also means that if you can do everything using an API, there's also going to be a very, very large HTTP API surface. And that's the first thing that we did when we introduced that API. We decided to bring an HTTP API playground in space. And again, this is a little bit of a product demo, but I want to show you that how everything that is in space actually maps to the SDK later on. So in space, you'll find the HTTP API playgrounds, and you'll see that everything that you can do through the UI is available there. So for example, if you want to get all absences of a profile or in the entire organization, you can actually get that. And here in the request builder, specify dates. So let's say for this week, I want to get absence information. What you will see is that you can execute this and you will get profile information and so on. What you'll also see is that some of the profile information in there is just an ID. So there's no name in there. There's no team for that profile in there. So it's a little bit limited. The reason for that is that by default, space, the API will just return you what it thinks is relevant for the request that you are making. So typically, if you want to get all absence events, probably you're also going to match that against some profiles and do some additional logic with that. So by default, we only give you IDs because that allows you to quickly start working with things. If you actually want the event description as well, you can enable that. You can add a location, a reason, the actual dates as well. And if you now execute that request, you'll see that you get more information back. So you get the fact that this is a vacation, when it starts until when it runs. So you'll see all that. What you will also see is that in the URL, those fields that we just added have been added as query string parameters. So a little bit like in a GraphQL solution where you would specify how you want your data to look like, what data you want to retrieve from the API. In space, you will be able to also specify that you want events, and for an event, you want the description and the location and reason and since until. So you can really specify what data you want to get from space. Reason for that is the smaller requests you make, the faster things will be, the faster lookups will be, because there's no need for space to go and look up related data if you're not going to make use of that. But by default, most of those things will give you information that matters for most scenarios. So if you get a profile, for example, you will see if I get, let's say me, if I execute that, you will see that you get back the name, whether they have an avatar and what the ID of the avatar is. So you'll get back some information by default, because again, we figured out that if you want to get a profile, this is probably the information you want to work with. If you, however, need for some reason people's absences in one go, or you want to get their manager, again, you can specify the fields that you want to retrieve there. There's also a couple of other specific things in this API, and that is that requests can have parameters, and very often those parameters are around a profile or a team or something that is an entity really inside of space. Now, instead of creating multiple endpoints to get profiles by ID and by username and just a me endpoint, what you'll see here is that there's different types of formatting the request parameter to get either me, which you will see in the query string that we're now just getting profile me. If you want to get a specific username, and let's say we want to get, let's pick the first one in the list there. If you want to get a specific user profile, you will see that if you want to get them by username, that the query or the URL now is username : and then their username. Same with ID. So there's different types of getting the same information, just with a different type of identifier in there. So this request builder is there. There's history there as well, so you can replay previous requests if you want. For our Kotlin SDK, we already give you some examples of how you can do that. That's going to come for the .NET one as well. But the idea is that we want to make it as easy for people as possible to start working with the API and build their integrations. Right. I talked a little bit about these fields. I'll give you a little bit of extra background information there. So by default, we return typically the top level fields, unless you specify that fields query parameter in the requests. Now, if you do that, you will no longer get that default. So if you don't specify it, you will get typically the top level fields. If you specify, I want the ID, you will no longer get the name in this case. So in that case, you'll have to be specific and build the shape of the object that you want to retrieve there. You'll see that you can also use the asterisk there, which will give you access to all of the fields, plus in this case, boards, and for every board, the ID and description. You can keep nesting just by adding additional brackets and so on. So it's really rich to shape how you want to retrieve that data. Now, a good question could be, why don't you use GraphQL anyway? Because this is very much like GraphQL. Reason for that is that this is the same API type that we already kind of had for UTrack, one of our other products. And we decided, well, if our users are already used to building integrations that way, maybe we can take the same concepts and continue working with that in space as well. All right, with all of that background information, let's breathe a little bit and think there's lots of API in there. There's some specifics in how you get that data, both in terms of the shape of the request and the shape of the response that you want to retrieve, as well as in terms of query parameters or path parameters to get things by ID, by username, by whoever is logged in, etc. Cool. Let's finally start talking about the .NET SDK that we built for this. So again, I mentioned that with Space, we want to make it easy for people to essentially drive them to the path of success or into the pit of success. We want people to make it easy, or we want to really make it easy for people to start using Space, build integrations, or maybe change existing integrations to integrate with the product. So the idea was, let's, for Kotlin and for .NET at least, and probably in the future some more programming languages as well, provide a ready-to-use SDK that you can start working with. That makes it very discoverable on how you can do certain things as an integrator, and to also make it so that you don't have to configure a lot. Essentially, if you look at the SDK, what we'll need is the URL to your Space organization, a client ID and a client secret, and that should be the minimal configuration required for a lot of operations. Now, looking at that huge API surface, we were thinking about maybe handcrafting things and making things really nice so that you could start using them, and they are really built by a developer for a developer, so it's easy to figure things out. We quickly decided to not do that because there's over 150 API endpoints, again, also with different variants in terms of ID, by username, by whatever. There's over 700 object types in there, and I think by now it's close to 800 even. This is a bit of an older slide there. And during our EAP, which we've had running for over a year, we still had a lot of churn. And endpoints were changing based on user feedback. We were changing the responses that you would get back, etc. So there was a lot of churn, and the last thing we wanted to do was for every release, re-handcraft certain things that have changed and test everything and so on. So no handcrafting. So what do we do next? We looked at using OpenAPI and using NSWAG to essentially generate an API client based on the OpenAPI documents that Space exposes. I mentioned that we're reusing some of the things that we already had in UTrack, one of the other products. That essentially involves an OpenAPI endpoint where you can get an API definition. We decided to try this on Space as well, but we found that there were some shapes that are not really compatible with how you would typically do things in .NET, and code generation quickly started to get cumbersome by just using OpenAPI. Also, everything that came out of this code generation was not really developer friendly. Typically getting absences, for example, in this example on the slides, was essentially getting absences with a string fields. What do you put in fields there? And with an object that is called body, with a member, reason, description, is this all mandatory or can you omit certain values? How does this work? Generating using all of the defaults didn't really work, didn't really give us a developer-friendly API. On top of that, we looked into customizing the OpenAPI code generation, but we quickly found that we were essentially rewriting an entire code generator. So we decided, okay, we already have an HTTP API model that we're exposing using the same primitive structures in the API. Why not just build our entire own code generation pipeline there? So if you look at the URL that is on the slide there, you can actually get the HTTP API model from Space. I'll quickly maybe show you in the playground here. There is an HTTP API model endpoint where you can say, for example, I'm interested in all of the enumerations that are available in Space and get their ID and name, and you'll get, there's an absence list mode, an access type, an application type, a busy status, things like that. You can get the values as well. So again, same structure where you can specify how you want to get that information, and the API will give you back, there's an absence list mode with these values and so on. So having that endpoint essentially gives us access to all of the object types that are available in Space, but also to how they relate to each other. For example, you can have a profile that is also a manager, or you can have a user that is also an administrator with extra fields and so on. The API gives you a very rich object model, and by actually using the metadata that we have in there, it is possible to also bring you that model, that entire rich model, and really give you a proper .NET SDK, not something that feels like you are passing objects over HTTP, but really something that is an object model where you can do things and where you feel like it's a proper framework. Again, that enumeration model, what you would get from the HTTP API model endpoint is something with this structure modeled in .NET. You would get back an API enum with an ID, a deprecation notice. If you want that as information, you can get back the name and the values. As we've seen in the playground before, you'll see that this is exactly the structure that we have there in the model. So you can get back that information. If you have that, you can parse it into C# using that object model that we had on the slides, and you can start generating code based on that. So this is really the model. You get that information. We had to model these classes manually so that they correspond with whatever the HTTP API endpoint was giving us. But other than that, we could start writing code generators. This is a very, very simple, naive implementation of something that would use that enum model, and based on that, start building an actual enum, writing it to a string builder. What you will see is that we indeed use that API enum, create a string builder, check if there's a deprecation. If that's the case, write that one out. Then write a public enum followed by the name of that enum, then an append line with the accolades to start the actual values of the enum, etc., etc. Just essentially build a string of C# codes that we can write to disk and then ship in the SDK. And what comes out on the other end is something like this, where you actually get that data from the model, run it through the code gen, and then get some C# codes. Right. Enums are kind of easy. DTOs, the data transfer objects around absences, calendar items, code reviews, things like that, are slightly more complex. They also have an ID. They can be deprecated. They have fields, like a class would have fields. This DTO model gives you access to those fields. Each field will have a name and a type, which can be a string, a Boolean, a date, time, things like that. Whether that field is optional, whether there's a default value. So you will see, based on this model, that Space is really giving us a lot of information on essentially building out those classes just from that model. You essentially get a representation of the objects like you would have to generate them on the other sides. Endpoints are even more complex. So I showed you that you can have requests to multiple endpoints with those fields, and you can have parameters of different types and so on. This is a class diagram of the endpoints model, so I didn't include an example on a slide here. Suffice to say, this is a really, really rich model that was definitely suited to start generating code with. All right, let's have a look at some examples that we are generating. So the JetBrains Space SDK is available on GitHub. It's open source, so you can look at the code. If you see something interesting that you want to check afterwards, you'll be able to find that and see what is there. There is on GitHub, there are 2 projects. So if you go to github.com/space.net SDK, you'll find our space.net SDK sources. If you want to make a trip to a different language, what you can also do is make that space Kotlin SDK, which is using similar concepts in terms of code generation, but you can also look at the sources for that one. So again, this is all live and you can look at whatever is in there with a little bit of background on how you can get started with it. All right, let's look at the code. So the project consists of really everything that there is related to the .NET SDK. So there are some sample projects in there to build an app, to build a command line application that sends a message to chats. There's a little website that gives you a dashboard and so on. The actual source generation is in the jetbrains.space.generator projects. What this one has is a program that will parse some arguments and so on. And essentially what it will do is it can either run based on a space organization URL, access that HTTP API model endpoint and get the model data. We also run this on our build server where we already have that data. So you can also pass it a JSON file with that entire model and start from there. Other than that, nothing fancy here. It's essentially parsing whatever exists in the API. And once we have that, we start deserializing into an API model class, and then from there execute the code generator. Now the code generator works on top of the API model, and let's maybe first have a look at what that API model looks like. So this is essentially a C# representation of what we just saw in the HTTP API playgrounds, where we have on that API model endpoints a list of DTO, a list of enums, a list of URL parameters, resources, and so on, and essentially deserializing all that in this model. Nothing really fancy. I can show you the enumeration is there, which maps pretty much to what I had on slides. There's that deprecation notice in there. So really just objects that we can deserialize the model into. Once we have that full API model, we have a code generation context that is being run. Reason for that is that the API model is very rich, but it's too rich for C# in a lot of cases. So what we are doing is creating a code generation context that does a few things to clean things up. So first of all, it will create a map of all of the enums that are there so we can do a lookup by ID. It will also remove some DTO fields that have explicit ignore annotations on them. We are also removing the DTO prefix from DTO names. So this is really a really simple method that essentially checks whether the model contains DTO, and we just strip off that string if it's a prefix. And if it's a suffix, we also remove that string from the object name. Reason for that is, again, we want the SDK to give you a proper C# feel. And having objects named something DTO kind of feels dirty and doesn't really feel like you can work with a profile or you can work with a profile DTO. I would like to work with a profile, a proper object in the object graph. So some cleanup is happening there. And once that is done in our program, let's return to our program, we run our API model generator. What this one will do is essentially write documents for endpoints, for URL parameters, for enumerations, and so on. I'll quickly dive into that enumeration one because that's the easier one to grasp if you look at it. So what this one does is for all of the enums that we have in code, it will write to documents the enum definition that we get from our model. What does this one do? Essentially also what we had on slides previously. We create a string builder, we do some magic and for example, call a to_C# class name method there to generate a proper C# class name from this enum. For a deprecation, we also write that to string using this extension method that actually writes out that deprecation. The 2C# class name one here, for example, essentially has a static object that does some cleanup because the model has classes that have invalid characters for C# identifiers in there. So this one essentially fixes those and returns a proper C# class name for the model. Once we have all that, again, we write a string that is just the enum, and then we write out whatever is in there. All of the generated code then goes into our client generated folder, and there you will see that, for example, for these enumerations, there's a dark theme.generated.cs. You will see that this is an enum that was generated with the values auto, enabled, and disabled, and their enum member attributes to actually give them or map them to a string value. Here, those are the same, but there are some cases where, again, we want to make it nice and C-sharpy, where this would differ from whatever we are passing to the API in space as well, because we want to make it nice to work with. You can run it, and if you run it, you will see that it will essentially contact the server, get that model, and then generate all files, and that should typically work within a couple of seconds. All right, 808 DTOs right now and 65 different types of enums. If you look at the commit chart, nothing will have changed because this is up to date and everything is there. But if you would remove that generated folder, you will see that in those couple of seconds, all of that is being created. The things that I really wanted to show here was one of those generators and the fact that we are using these extension methods to generate a class name, to generate a deprecation notice, to generate an identifier, things like that. So all of those are in there. Right. You may have also noticed that we're using string builder to generate everything. Typically in C# or in .NET, if you want to do code generation, there's actually a really good book about that as well. There's a couple of large ways that you can do code generation. One is intermediate language based, where you use reflection.emit and just write things using reflection. For these DTOs, for those request methods and so on, that is probably overkill, too complex, not very flexible to change. If you have something really high performance, small bit of code that you want to generate, IL based is probably going to be fine. For us, this felt cumbersome. There's model-based code generation. In older .NET versions, you had code dump, where you could essentially say, I have a class with these fields, these types, and then generate C# or even VB.NET from that. There's expression trees that you can use, and there's Roslyn syntax generation. I'll show an example of those in a little bit, but we decided to go with the string-based way, which is essentially a little bit lower level than using a template-based approach. We decided to just write C# code and generate strings to write code to disk. I mentioned strings all the way because if you look at a Roslyn definition of one property with a type in an object, what you see on the slide here is two examples. One is just writing a string that says public, whatever the type, whatever the property name, and adds a getter and a setter. Whereas the second bit is the Roslyn-based way of doing things, where you have a syntax factory where you create a property declaration with a type name, modifiers, accessors, things like that. To be honest, when generating a lot of codes, it will quickly feel very complex and not really readable. Just seeing those strings in your code base whenever something goes wrong in the code generation is really easy to spot where that is coming from, to update it, to actually see what the code is going to look like that comes out on the other end. You can use both approaches. We felt for us that the string-based way works best in C# for this case. A quick side note there, we are doing something similar for the Kotlin SDK. Kotlin also has a Roslyn kind of way called Kotlin Poets to generate classes based on a richer model. For the Kotlin-based SDK, we are actually using that because they have a lot of extension methods, a lot of fluent APIs that actually make it really nice to read, and it's almost like reading a string instead of this blob of C# codes that is the Roslyn-based approach. I mentioned that we have a lot of extension methods everywhere. And the idea behind that is that there's a lot of things that are repetitive. We need class names. We need to map types from the API into C# types. We need to be able to write documentation and so on. Those aren't really full objects. They are typically some helper method that will emit another string. So we decided to go with lots of extension methods on the types that they matter. So if you look at some examples there, you will find that this toC# class name exists in multiple places. So if you search for that one, you will see that it exists on enum, but also on DTO. So it makes it easy, regardless of which object you are working with to generate code with. You can just call a .toC# class name, and there is going to be an extension method that gives us access to write a class name into the generated codes. All right. System.tx.json, another interesting one that we ran into. When .NET 3 came about, Microsoft has been yelling that system.tx.json is a drop-in replacement for Newtonsoft.json. Turns out that messaging has been changed quite a bit in the meanwhile. We decided to use system.tx.json instead of Newtonsoft.json because we did not want additional dependencies brought in. But we did find out that it's not really a drop-in replacement. There are differences. Both are good libraries. But yeah, depending on what you're doing, your mileage may vary. For us, it wasn't a 100% replacement because there were some things that were missing. For example, polymorphic serialization and deserialization. If you have an object graph where you have a parent class, a child class, and a subclass of that one and of that one, it's really difficult to do that using system.tx.json. We also found that working with records and immutable classes was not yet supported. Meanwhile, .NET 5 came about and things are improving. But since we want to also target the long-term serviced release of .NET, we are sticking with .NET 3.1 while we're at it. Luckily for us, system.tx.json is flexible enough, and it's fairly easy to write your own JSON converter. I mentioned this entire talk is in a blog post. This specific converter that I will show you has its own blog post as well. So I'm just going to show a couple of things so you have an idea of how they work and how they can work. But there's a lot to them that can be discussed. All right. Let's look at one of those converters that we have there. So I mentioned that there's the client namespace. There's also a common project that has those tools that we use internally to do things. So for example, we have a space date converter because space has its own type of date time. What we are doing is we are registering a custom space date converter into our JSON serialization process to be able to convert that space-specific datetime into a .NET datetime. Couple of interesting things there, if you start looking at it, is that we want to support both nullability in C#8 and regular datetimes. And apparently using system.tx.json, you have to be able to use multiple converters for that because nullability or not is it's essentially a different type that is being passed around. The more interesting one is this polymorphic one, where it is possible for us to convert a class into something that has subclasses. So for example, I know there's an object called application payloads. That's a generated type. It's actually an interface. And that type has a number of implementations. If we go to the inheritors, you will see that there's a menu action payload, a message payload. All of those things are there. Space gives us back any of those 5, but we don't yet know which one. And we want to be able to deserialize that into the proper type when coming from the API. So this converter, what it does is it checks whether something has the iClass name convertible marker interface. If that is the case, it will read the class name property from JSON, see if we already have seen that type, just some caching that is going on there. If we've seen that type, it will then deserialize into the actual target type and not just the interface. So that makes it possible to have that class name hierarchy and have subclasses and things like that. One thing that I really want to stress here is that if you start writing your own custom type converters in system.tx.json, is that the reader you get is essentially forward only. So all of our subclasses have a property called class name, but if we read that, there is essentially no way to later on deserialize the entire object that we currently have in that reader. Now, luckily for us, that reader is a struct in C#, which means that by reassigning it to a different variable, all of this forward-only reader is being copied, and we can quickly check the class name that is on there, and then later on reuse whatever the previous state of that reader was. Just small side note there in case you ever encounter something like this. There's a couple of those. We have one that converts those enum strings based on the member attribute that is on there. So a bit of code in there. I would say if you're interested in these, have a look at the blog post or have a look at the actual repo and see what might work for you. But we have quite a few of them. All right. The thing that I really wanted to get to is that if you are generating code, if you're building an SDK for people to use, you actually want to focus on developer experience. Make it nice for people to use it. Ideally, you want to register an application in space, install a NuGet package into your project, connect to the project, and then start working with it. And you don't even have to read the documentation. That's the Uber goal that we have there. Make it possible for you to discover what is in there. Now we've seen there's a large API surface, but there's also that HTTP API playground that you can use. So we decided that for all of the SDKs, the structure of the objects that you have should match whatever is in the HTTP API playground as well. So you will see if you want to get all birthdays from your space organization, you will see in the space HTTP API playgrounds. That's really a tongue twister. You will see that there's a team directory where you have birthday events and then a get all birthday events service that you can call. Well, in the SDK, the code that is generated will give you a team directory client, the top level thingy. In there, there's a calendar events and then a birthday events property. And on that one, you can call get all birthday events and read whatever is in there. Again, to make it easy for people to discover how they can actually work with this, if you look at the playground, you will be able to also work with the SDK. For fields, that's an interesting one. Since you can specify which fields you want to receive or retrieve from the API, we also wanted to surface that in the SDK so that by default, you don't have to specify anything, but if you want, you can actually specify those fields, which is also something that we did. So by default, if you want to get the default shape of a profile, you can just call get profile async profile identifier.username, pass in the username and get that profile. If you want someone's full profile information with managers, with the ID and the username of that manager, you can actually append a lambda at the end and then type .width, and then code completion will give you information about, for that type, which fields, which properties you can actually request from the API. This is slightly verbose. It would be nice if we could actually make that nicer to work with. But unfortunately, unless anyone knows, please contact me because I would love to learn. But there's no good way to have a strong typed compile time check for whatever fields are there. If you use GraphQL, for example, typically you would have a string or something that is generated from that string. Here we wanted to have good IDE support so that you could just call whatever is there and start working with it. So that developer experience is there. Let's have a look at a couple of things that are there. So for example, in the samples project, large solution, you will find there's a command line sample where there's a couple of things that you can start working with. So what this one will do is essentially what we saw on the slides: set up a connection with your space organization, create a team directory client, and then from that team directory client, you can start working with it. So if you use team directory client, look at whatever is in the playground, you will see that you can get locations, you can get teams, calendar events, etc. So again, you can just start using code completion and get, for example, all of the holidays that are there. You'll see that there's a get all holidays async method in there as well. Now this is actually a nice example. So the API model also exposes which fields will be deprecated over time. And we also decided in the generated SDK to also give you obsolete warnings whenever something is going away at some point later in time. All right, so those things are there. If you look at the playground, you will be able to figure out how to work with that Steam directory clients. There's a couple of other things that we did in generating codes. I'll dive into those in a little bit. But I want to show you that we also try to help you be a better developer using this SDK. So for example, if you would get from that team directory client, you would get the all profiles. And for all profiles, you specify that you just want the ID. If you later on access a profile's name and first name, Space SDK will by default throw a property not requested exception and give you information about what is going on in there. I'll actually run this sample because I'm printing the exception message there. Where is my sample command line? Yeah, there we go. So if we run this, you'll see some of the test methods that are being executed. But at some point, you'll see this big red warning that says that the exception there happens. And you'll see that that exception tells us that we are requesting a member profile. But since we are accessing name, you'll have to use .with name to include that name. Ideally, at some point, we would like to be able to write some code analysis to give you this at compile time, or at least at editing time. Right now, it's a runtime exception, but still, it's more meaningful than just throwing and saying that things don't work out with this specific call. Some other things that we are doing when generating code is that, for example, getting all profiles is really a method that gets profiles using a query under the hood. We are building that entire name value collections of query string parameters for you. Defaults are being generated there as well for strings, for example, for Booleans. So again, you have a very easy way of figuring out how to work with the API there. And also having that rich model obviously helps in generating the correct things there. Cool. One that I'm really proud of is the way we handled batching. So when getting profiles, for example, or calendar items, typically the result set is going to be humongous if you have a good space organization. And what we're doing there on the server side is we are batching the responses. So you will get pages of results. I think they're by default page by 100 elements. So if you want to get the 300th element from a collection, you will have to page a couple of times to get that 300th element that is there. Now, batches are essentially an object that roughly looks like it has a list of data. It has a string that says where the next data lives, a total count, and a helper method that tells you if there's additional data available. Now, getting, for example, all of your to-do items would be something like the code you see on the right, where you would have to specify from until which data you want, then do a for each, check if the batch has more data, do another request to get more data. So very complex. You can do this today using the SDK that we generate, but we decided if we encounter one of those batch types, let's actually generate an async enumerable. And we'll do the batching under the surface for you, but we will make it possible for you to essentially enumerate over whatever to-do items are in there and do whatever. We'll do the batching for you in the backgrounds. One word of warning, we're introducing this shortcut to make it easier to work with it. This also means that we had to document that if you want to get a count, this is not the way to go because you will then enumerate all pages. If you want to get a count, you will have to use the batch enabled endpoint actually to get just the total counts on that batch that is there. So a little bit of a double-edged sword. On one hand, we're making it easier for you to get all data or loop until a specific item in the result sets. But obviously, we can't cover all bases. So if you want to get the count, you'll actually have to think about that and not iterate over all of the results that are there. I'll quickly show you how that batch enumerable works internally. So getting all profiles, we were actually there. Getting all profiles using that async enumerable is essentially a shortcut function that calls into batch enumerator.all items, and then under the hood calls the actual methods that returns a batch of user profiles. So we are embedding, or we are wrapping the existing methods that we are already generating with essentially an overload that will run the batch request for you. Now, this batch request will make use of our batch enumerator.all items helper methods that we use there. And what this one will do is essentially execute the retrieve batch, getting one batch of information. For every batch, it will run over all pages and for each, and essentially just return items of data that are there. There's some cancellation token support in there as well. So if you break your enumeration or you have a cancellation token that fires, we actually stop fetching new information just so we don't keep stressing the server or stressing the memory of your application by getting more data. And again, this is a nice and elegant way of going over all pages, and then for every page going over all of the data that's in there. If you are at the end of one page, then you will get into this for each again, get the next page, and then start working on that data again. All right. I hope everyone's okay with me running over time about 5 minutes, because we're not there yet. Right. One other thing that we're doing is we are flattening request bodies. The Space API also requires us to pass in, for example, when getting absences, to pass in an object that has all of the parameters to get that object. Some API endpoints use query string parameters. Others really require a body because there can be a lot of information in there that does not really fit into a query string. So get absences is one example. Generating that open API based codes actually gave us such a request object as well. In our generator, we decided to actually pull that out. We're still using such an object internally, but exposing to you as a user, we are just exposing that get absences with all of the different parameters. So you don't have to worry about whether something accepts query string parameters or actual request body objects. There's also factory methods for inheritors. Instead of having to, for example, when you want to send a chat message to a channel, instead of having to use new message recipient channel, and then the channel is going to be a chat channel from name and then passing the name, we decided to also generate some static helper methods that make it easy for you to achieve what you want to do. So if you start typing send message async, you will see in code that code completion will suggest you to use message recipients.channel, .issue, .profile, and so on, depending on whether you want to send to a channel or do a direct message. All of those then take a chat channel, which can again be from ID, from name, or something else. So also that is generated and gives you some information of what is available there. I also mentioned that we are generating default values for enumerations, for primitive types, and so on. Unfortunately, in C#, this does not yet work for reference types, but luckily for us, I think there's one method in the Space SDK that currently needs that, and we found a little bit of a workaround for that. But generally, if there's default values, we also write them into your codes or into the generated codes. So again, you don't have to pass in the default if we already know what that default is going to be. Right, some quick examples there. I want to show you how you can send a message to a chat channel. So typically, if you want to do that, what you will do is make use of the chat client. I'll actually just show the existing code there. You'll make use of a chat client and then send message async to a channel with a channel name. Content is going to be a chat message.block. So note that we are not saying new chat message of type block, but just chat message.block. Where you can then start adding sections, message sections, and so on. This is not as clean as we would like it to be. And actually, if you look at the Kotlin version of this, there is a chat client that you can use. And in that client, you can say clients And I know this looks a lot like C#, but it's really Kotlin. What you can do there is to the chats, you can send a message. I'll actually show the existing code that I had in here previously. But what you can do is send a message, and there's a little bit of a DSL there where instead of still having to new up some objects, we have some helper methods that allow you to define a section with text and buttons and things like that. In C#, this is still a little bit more verbose, where you have a list of sections and then have to pass in a message section. Luckily for us, if you are using C#9, you can actually make use of these, and things start getting a little bit more readable without cluttering all of the type information in there. But we would like this to be cleaner. And again, if you have a good idea of how this could be cleaner, let us know. I would love to learn. Right now, this is what is being generated there. All right. Speaking about developer experience, you may have noticed that there's the generated codes, but there's also a ton of helpers and things that you can use in your application as well. We decided it's not enough to just give you an SDK to work with to connect with an API somewhere. We also want to make it easy for you to, for example, do single sign-in using Space as your identity provider. So we have done we've added some authentication services there that allow you to make use of Space. We also added a .@space token management there, which I think is very interesting because that allows you to reuse the currently logged user's identity and act on behalf of them to access the APIs. So if you have an application where a user has to sign in using their own profile, and then all of the requests the application is making to Space have to be authenticated as that user, just adding those two lines will actually get you there, and all of the API clients will then be authenticated as the currently logged in user. Adding Space API client is also simply just saying services.addSpace client API, and you will get access to all of the services from within whatever class you are using. Also for receiving calls from webhooks in Space, there's some helpers and so on as well. I'll not go there. I'll jump to the conclusion instead. There's lots of examples in that SDK to be found. But I hope if there's some takeaways that you take away from this sessions, that ideally you learned that JetBrains Space is there. It's a chat meets issue tracker, meets CI, meets a team directory, meets a calendar. So all of that is there. There's an HTTP API for everything that is in there. You don't have to figure out how that SDK work or that API works by yourself. There's nice SDKs for .NET and Kotlin. We generated those to make you successful using Space. Yeah, there's a lot of thoughts that goes in there to make it easy for you as a developer to make use of that. And I just wanted to show you some of the approaches on how you could write your own SDK for your own product that you may be building. But I think the main takeaway here is if you do something like that, if you build an SDK, always focus on developer experience, build samples, actually use your own SDK so that you learn where the pain points are and that it's really a one-way street towards success. With that, thank you, Luke. If there's any questions, feel free to ask. Blog post is live. Find my blog. I think the latest post is actually this talk as well. Yeah, and explore. Thank you very much.
Great, cheers, Maarten. Yeah, that was great. I'll post up this event probably tomorrow morning by the time it's done rendering. I haven't seen any questions come in to the chat box unless anyone does have anything. But yeah, for those who heard me at the beginning of the session, we're announcing the next session, which I can say is going to be with Dylan Beatty. He's going to be talking on open text, so that's going to be fun. Yeah, so just getting a few messages in the box, just people saying thank you. If you do have any questions whilst Maarten is still here, obviously make use of him. Otherwise, of course, this talk is going to be posted up on YouTube. And yeah, obviously just more thank you messages. So I presume you explained yourself thoroughly enough, mate. So nothing yet. All good. Well, if that is it, thanks everyone who stayed to the end. And yeah, we'll see you at the next one.
All right. Thanks, everyone.
All good. Cheers, Martin. Thanks very much, man.
Yep.
Bye.
Bye.